Today in Crazed Performance Repair, I am sitting among several engines here, some together, some apart, and we're going to go ahead and go over a few different details between the different engines and the evolution. This is obviously the oldest engine. This is a 60s engine. This is the more modern, early to late 2000s engine, early to late 2000s. And then this is a much newer engine. That's a 2005. Let's go ahead and cover all the differences of what all these engines are and just kind of do general engine talk. It'll be interesting to look at the different evolution of things since I have all these motors here right now. So we're going to go ahead and start off on the left side here. This is an old small block Chevy. This is like, this basic engine has been made since probably the late 50s, I would say. I'm not real good on my history, but it was made all the way up until 99, I believe, was the last year of the small block Chevy. In this format with this style of block. Though the block has gone under many revisions over the years, it was always this style of block. They just changed the heads and upper end throughout the years. But one thing they kept the same with the cylinder heads was on the side here. The exhaust ports are called Siamese ports in the center, so it's got two ports next to each other and then ports outside. And I think that might be what ultimately killed this engine, turning it into that engine. So what do we have different from this engine? So this is a 60s-ish, early 70s engine. And this is also a modified engine. So it has aftermarket heads, aftermarket intake, and pretty much the whole top end is completely aftermarket. And then of course there's some aftermarket pulleys on here. This is a performance build, and I need to go through it. But we're not here to worry about what I have to do to it. We're just here to talk about some characteristics of the different engines. So we're going to go ahead and look at a couple of things quick while it's sitting here. I did take bolts off of that and the intake here so that we can cover a couple of things. So this engine, we're going to compare directly to this guy first. And the reason we're going to do that is because this guy is the replacement for this guy. So this is the LS-based engine. It started in the mid to late 90s, I think late 90s, as a LS1. It was a 5.7, originally a 5.7. Now, this is a 350 or a 5.7 as well. There was all kinds of different revisions of this motor, different bore strokes, etc. Just like that one ends up with later on. That one, as an LS1, which is why we call them LS-based engines, because they are based off of an LS1, is a direct derivative or update from this engine. This engine has several differences though. So basically, this is a 5.7. They decided to make a new 5.7 that changed the way it was set up, and we're going to cover some of those changes as quickly as I can. Notably, the top end. That is where most of the change took place. So we have several differences to the top end of the motor. You can see right here, this is the valley of the old style motor, and right here would be the valley of the new style motor. Now the heads would come up here, there would be a wall like this, and this would be the cylinder head. Now this one, the cylinder head, it does not, like there's a bridge here, right? And that portion of this engine is solely for the displacement on demand part of things. And the lifters are below the head, just like this one, they're below the head, but these can be removed without removing the head, whereas these cannot. The head has to be pulled in order to remove these lifters, because there is a bracing or a material right here that does not allow access. And that's because of the displacement on demand ports. Most of the people watching my channel know a lot about this because I cover that in huge amount of details. I came up with a shortcut to release these lifters. So that's kind of like the main difference between the two engines. There's a couple minor differences that are very small, notably on the crankshaft. So the crankshaft scenario, it has a different pickup wheel, it has a different rear main seal setup. But aside from that, it actually has the same bearing sizes. As far as the rod bearings go, I guess I never really looked at the mains. I think the mains are a little bit bigger on the new one. But the rod bearings are the same size. They are interchangeable, which I find interesting. It's kind of cool, though, because me being in the performance world, I can build a small block Chevy and the leftover bearings, because I usually buy 2 sets, one slightly extra clearance and one with slightly tighter clearance. That way I can mix and match and get the clearances I need. So that allows me to take whatever bearings I use on these and still be able to use them on these. It's kind of cool in the performance world. So interesting fact that they did that, but the camshaft is also a little bit different. So in the block, this block has a camshaft that is raised up slightly. The nice thing about that is it allows for a little more stroke, less interference issues with the crank coming in contact with the camshaft. So it gives a lot more room for performance upgrades later. The huge drawback with this block, when it comes to an iron block, the iron version of this block is insanely heavy compared to this block. So this one originally comes with cast iron heads, which makes it weigh about the same as this, because this comes originally with aluminum heads. But you put a pair of aluminum heads on this block and have an iron block for both of them, this one's going to be a much lighter block. It has a lot to do with the webbing in the block. I'm not sure where all the weight comes from, but there's a lot more material in this one in places that is kind of, in my opinion, unnecessary. But these are, there's pluses and minuses to both of them. Okay, so lifters. What is different about the lifters? This is where we get into some advancements in technology from this version to this version. Now, the lifters in this guy originally would be what's called a flat tappet lifter. Now, if I were to pull these out, and if it was a flat tappet lifter, what it's going to have is, it's going to look like this guy here. It's going to have the hydraulics on it just the same. The only difference is instead of having a roller here, it's going to be a flat polished surface. It just rides metal on the cam with the oil film in between to protect it. And that style camshaft was used for a very long time because of affordability. It's a much cheaper lifter to make, so it made the motor much cheaper to make. Now this one here is a roller lifter, and that's what's in this guy. But this guy, the first generation of this, only had these. And if I remember correctly, the LS one did not have these in place yet, or maybe they just weren't drilled out. I don't know. I haven't really worked much on the LS one because it just, before I started doing the performance thing, it had kind of phased out and everybody was using this style of block at that point. But this guy here, there's 2 different lifters on this motor. So let's switch over to this motor quick and cover what they did on this guy to change between the 2 engines. So we obviously have 2 different lifters here. This is an AFM lifter, a non-AFM lifter, and this is obviously to shut off the valve train on whatever selected cylinder. So any of these cylinders with these guys lined up with them is going to be a displacement on demand cylinder where it shuts the valves, just leaves them shut. The system is highly prone to failure. If you have not seen any of my videos on it, I do have a Chevy specific category that has all kinds of these videos for a playlist. I have all kinds of these videos in there. Maybe I'll throw the playlist in the corner, but I have all kinds of breakdowns and information on this style lifters, this entire system. Now, another huge difference between this engine and that engine is actually on the intake manifolds themselves. So on this style of engine, you're going to have a plastic, or nepholic I think is the word, I don't remember the word, but it's a plastic intake, and this offers huge bonuses compared to this one, especially since on this one here they run the coolant passages through the intake. So now this is, since this is the old school style, you have the coolant passage going through here. This is where the thermostat sits. Much easier to access the thermostat, I must admit. And then you have a distributor coming through here. Now because of the distributor and the coolant that is going through the cylinder head and the intake manifold, so there's coolant going through it on this side, and then this just has coolant block-offs on this side. But because of that, when you pull this intake manifold, it's much messier. You have to deal with coolant and everything else. This style, when you do not, there's no coolant passages in it, and there's also no distributor going into the back of it. This one has a distributor in it, so it makes it much more challenging to deal with when you have to pull this guy apart in respects of the distributor. However, in this era, they didn't have all the electronics. So this specific era, at least you don't have to deal with that. It's the simple carburetor and a few bolts, and then you have to make sure you get your distributor set up properly and drain the coolant. The newer versions of this with fuel injection, however, have all kinds of different versions. One has a spider assembly in it, and those are a real butthole to work on. They are quite the challenge because not only do you have an upper plenum that's plastic to take off of the aluminum plenum, but you have a bunch of emissions garbage hooked up to it, and on top of that you still have the distributor you still have the coolant passages, and you still create a heck of a mess. So the newer ones, like the early to mid 90s versions of these, are just a pain in the butt to work on the old 350. Now, the LS-based ones, when you have to pull the intake, whether it's a car intake like this LS3 intake, or a truck intake, which is a much taller, different looking, not as neat looking intake, they are very, very simple to remove. It's a few electrical connections, a fuel rail connection, you unplug the fuel rail, a couple vacuum lines, and then you're pretty much ready to unbolt the 10 bolts that are holding it in place. Unbolt the bolts, lift the thing up, get it out of there. There's no coolant passages, just airways, that's it. So you don't have to worry about anything leaking out on you. You don't have to worry about a distributor. It's a simple few bolts and a few connectors, you're done. The only thing that makes any bit of a mess is the gasoline, and that evaporates. So, really nice that they went to this. Plus, this offers a ton of bonuses. So, the plastic intake is pretty much what everybody is going to now, which is one of the advancements of the future. Now, one of the other advancements that has happened is in the valve train and valve train timing control. This engine has static valve train. It does not change no matter what RPM or what you are at, no matter what you do. It does not change within reason. I mean, chains stretch as you're at higher RPM because there's more moving parts, things are flexing, things like that. I'm not counting that. I mean, theoretically, on a data sheet, it does not change. So, there's no active timing control. This system, however, on this particular motor does not also have timing control, minus the DOD lifter, so it does shut off the valves. But a lot of these vehicles will have a big VVT gear right here. I have one in the basement. I should have grabbed it. I should have brought it up. But there will be a big VVT gear right here and a solenoid button with an electric solenoid on the timing cover that will push on that button, allowing oil to activate the variable valve timing. So it can advance or retard the cam depending on what that solenoid does that activates the button. So these motors are starting to get a little more complicated in that they have that kind of option. But that brings me to the next set of engines, which are the more futuristic style engines. They're where the future is heading, and only the beginning of where the future is heading. So here we have a Ford 2018 Mustang 5.0 liter engine. It's got dual overhead cams, and this is just the block, obviously. I don't have all the parts here. I have a lot of things at the machine shop. And this guy here is a Mercedes-Benz AMG engine, and there's something kind of unique but kind of cool about this engine that you don't see very often in the automotive world, which we will cover in a little bit. And then there's something quite unique that for the first time I've seen on this engine block. I'm sure it's been around a while, but it's the first time I've actually seen it in person, and I was actually confused as to what did it when I saw what it was. And I am going to have a whole video series on this engine, so I won't cover very much on it, but I will compare it to what's going on here. Now this guy here, this is a 2005 AMG. So this guy has a supercharger bolted up to it, and it's forced induction, which has obviously power enhancement things going on, but it does create some heat, and it does make it an aluminum manifold. And so this has a lot hotter air intake temps than this guy does. This guy has the plastic manifold. This one here, it has direct injection, and it also has the port injection. So it's got 2 injectors per cylinder, and it's controlled kind of interesting. So it's got a high pressure pump, a low pressure pump. The low pressure pump feeds the fuel rails that go into the intake ports. The high pressure pump feeds the fuel rail that goes to the cylinder itself, which is something that they're going to on motors too. Now, the new generation of the LS-based engines also has direct injection as well. So that's another one another thing that's changed with that specific engine series. This one here, it has a couple of things going on that pretty much have been going on forever. So for a very long time, they have gotten into dual overhead cam engines, 4 valves per cylinder. That's 2 valves, that's 2 valves, 4 valves, 3 valves per cylinder. And this 4 valve per cylinder engine is what a lot of the smaller 4 cylinders have done for a very long time. But you have dual overhead cams, you have a cam phaser on the main camshaft to change the overall cam timing on that bank. Then you have a cam phaser over here to change the overall cam timing on this bank. And then, of course, you can also have things like a secondary cam phaser system, or you can have two cams, two cam phasers. It all depends on how they decide to set up the engine. I don't know this specific one, I forgot. I think it has a single cam phaser that only controls the two cams. It might have variable overlap. I don't recall, but it does have, you know, a lot of engines do have where they can change both camshaft timing, which is very nice. And there's something else they're adding to the mix. Hyundai specifically has come up with it. It's variable duration camshaft. It's a very interesting thing. I might actually link somebody up in the corner above that I have watched on this subject. He covers the topic very well. It's very cool to watch because of the way they're advancing things. This guy here has 3 valves, so it'll have 2 intakes, 1 exhaust. But the unique thing about this engine is it has an allofill cylinder wall. So looking at all these motors, you can see the different cylinders except for that very last one there. That last one is all cast iron. The cylinder walls are cast iron. The entire block is cast iron. This guy here is an aluminum block, cast iron sleeves that were inserted during a temperature change kind of a thing. I believe that's how they put them in on these. This one has a sintered cylinder wall. Basically, it's lasered on cast iron, which is very unique, and the first time I've heard of that, or seen it in person. I'm sure it's been around for a little while, but it's the first time I've seen it in person. It makes for a very thin cast iron cylinder wall. So that cast iron cylinder wall obviously is good for wear characteristics. However, the allofill cylinder wall is also very good for wear characteristics given the right components to match it. Now, what is allofill? So basically, allofill means you have an aluminum cylinder wall, an aluminum bore, but it's treated to bring the silicon. It's a special process that brings the silicon in the aluminum out to the surface of the cylinder wall. Now, the silicon creates a very slick, slippery surface. It also makes it extremely hard to do any kind of cut or anything to it. And the reason it's so hard to cut is because that silicon is so slippery, a cutting bit just has trouble cutting it. So this is a very unique and cool process that this Mercedes-Benz company is using, and this is also used a lot in motorcycles. So the motorcycle world sees it way more than the automotive world, but the automotive world does see it too. Now, we got a couple other differences with timing components on the front of these engines. So this block here does it one way, this block here does it another way. Now you can see this is going to be where the water pump goes on this block here, and then the timing chains kind of go up like this, right, and then come around, and they go in here. And these are going to go the same direction. However, they did it differently here in that the block doesn't have like a recess section, and instead the recess section is in the timing cover. This block here, if I were to take all these little pins out, would have a flush surface on the front of this. Now you have a couple coolant passages here. This one has the water pump built into the timing cover instead of built into the block here. And then this one also has a cartridge filter, which is really nice, versus a canister filter on the rest of these engines. The cartridge filters, I actually like that idea. It seems less wasteful. You don't have any metal encapsulating anything. The metal's already built into the block. I do like that system a little bit more. It makes the filters cheaper, easier to inspect. I really like the canister style filters, but very few of the performance engines I get to work on have those. One thing that has changed over the years is the main girdling or main strength area for the mains on engines, and this is something that has become kind of a trend. They really like to strengthen the bottom ends for the main caps. So on the old engine that I have sitting over there, a lot of those were only a 2-bolt main. So what do I mean by a 2-bolt main? Well, let's go ahead and flip all these over and take a look. So on the old small block Chevy, which is sitting over there, I don't have the oil pan off, so I'm not going to go over that, but the main caps, instead of having, you see this has 4 bolts on the main section bolting it on here, and it's also got 2 bolts here. The difference between this and what they used to do is only have 2 bolts on a lot of them, and this motor over next to me is actually a 4-bolt main, and that means it's just like this one, only it doesn't have these side bolts. So they had 2 bolts, 4 bolts, and now they have 6-bolt mains. Now this one is a 6-bolt main, that one is a 6-bolt main, the Mercedes is a 6-bolt main. So it's becoming a trend to really get strength on the bottom ends of these motors. Not only does the multiple bolts going in from this direction and this direction help with holding the crank still, but it actually reinforces the block quite a bit, a considerable amount. Some companies are actually, in fact GM in the 90s and early 80s or late 80s had a V6 where they bolted the main to the block, then the oil pan went on, and the side bolts came in from the oil pan. So it would take and integrate the oil pan into the strength of everything really well. It would tie everything together. And a lot of companies are starting to do that as well. So that's kind of an interesting little change that they've had as they keep advancing with all these different systems. And then one last quick little thing that I wanted to comment on, two last quick little things that I wanted to comment on, are windage and the starters. So this one here has an opening here, and then there's an actual starter thing on the other side. This is the Ford. The GM only has the starter on one side, I believe is a possibility, yep. So the GMs only have starters on one side, but what I've noticed is a lot of German cars, BMWs and Mercedes alike, and I think some of the Audis and Volkswagens are doing it too now, they have a starter hole on both sides. And that is depending on the specific build of the car so that they can make the block fit the car. That way, if they need a starter on one side versus the other side for some kind of clearance reason, they can do so. It's not going to be a big deal, which is kind of cool that they do that. Now, the last thing I want to cover is windage. What have they been doing with windage over the years? So we're looking at the motor with the crank in it and exposed because we want to look at what's happening inside here. So as this thing is spinning, right, it's just, you can see these counterweights coming up, and then of course you got the rods coming up, and all these parts are moving all over the place. They're moving crazy, right? So there's wind stirring up everywhere. Well, what all the companies have done now, pretty much all of them I believe, up on the current to-date stuff, maybe not the old small block Chevys, but the current to-date stuff, has what's called a windage tray in here. And that windage tray has cutouts in it, and it's to catch the wind. As this thing is spinning, it's creating a circular turbulence. Well, it takes and it catches that wind and traps it in the bottom of the oil pan. Now, that is only a part of the wind thing going on inside engine blocks. The other thing you have to consider is that piston is coming up and down, up and down, up and down, right? So every time it comes down, it pressurizes this main section. So it pressurizes this area, and then as it goes back up, it releases this area. If you have two pistons that are down at the same time, and I'm watching the pistons now, and what I notice is it seems like every one of these, because of the way they timed it, has one piston come down, then the other one comes down right behind it, and then it goes up and up. So you're basically bringing two sections of air into one cavity on every one of these cavities. So when it does that, you want to get that wind out of there. If you have a plate covering this, you have no real good way to get that wind out of there. What they have been doing in these blocks now is they have not only been having these little holes right here that I can stick my finger through on these areas, but they've been taking the blocks and cutting a hole through the block. And they're doing that to create an area for the wind to escape. So when these two cylinders are coming down, those two cylinders are most likely going up. That gives it a place to transfer the air back and forth. That way it's not having to build and compress any kind of air. It helps with fuel economy, making it a little more efficient. So the block that we just looked at was the Ford block for the Mustang. Now this block here, being an aluminum block but for a truck, I don't believe has the windage slots. Yes, there is no windage slots in this one aside from the mains here. Now this is going to be a much better block for a performance build because it doesn't have those, and you could pull a vacuum on it to eliminate having a windage issue in the first place. But the LS3s, for like the Corvettes for instance, they have the windage slots built into them. And the windage slots actually cause a really big problem when you start adding a lot of power to one of these LS-based engines with windage slots and an aluminum block. Now, this is the main cap and part of the block on an LS2 engine. And you can see right here is where the piston would come down to. This is the cutout for the bore of the piston. And then you have the casting material right here. And this section is not broken. This spot is cut and then broken off the rest, and then I cut right here. So you have a connection to the block here, you have a connection to the block here. This section is where the camshaft goes, connection to the block, connection to the block. So you really don't have much holding this thing onto the block, and you're relying way too much on this bottom cap, which is bolted to the top cap minus these two little piddly bolts. So they are not very good for performance. They flex and move a lot, and if you want to make any power out of one of these motors, you got to give excessive amount of bearing clearance on these motors to make up for all the movement that happens when the block is under load. So this has become a problem for the performance world with the aluminum blocks in the LS based engine style. So that was one last note I wanted to cover on windage and the overall evolution of several different motors while I had some here. Now, if you want me to go into a little more detail on engines in regards to variable valve timings and all the different things that have happened, I only touched a very small fraction of what they have been doing to change how they control the air going in and out of engines. And if you want me to touch a little more on that, let me know in the comments below. I would love to make sure that I get some more information that you want to know about on these different topics. Now, I have covered some information in regards to cylinder head airflow characteristics on a couple of my engine builds that I've done. They are older videos, so the information isn't quite as packed and dense as I make it today, but they are still very good videos. They still have a lot of information, and go ahead and check some of those out. I'll go ahead and throw a link to the most suitable engine build that I feel at the moment is available. So I'll throw a link in the corner for that one. And with that, be sure to hit the like button. If you haven't subscribed yet, hit that subscribe button. You watched it this long, you apparently care to watch my videos. So I have a lot of watchers, very little subscribers in comparison to the people watching my videos. So be sure to hit that subscribe button if you've been watching my videos. I really appreciate it. I appreciate you just watching in general. Thanks for watching. I hope to see you on the next video.